As we've seen, the plan and document processes rely heavily on heavyweight documentation and a project manager who can keep track of it. And the question is, can we do something that is more than just hacking? So not just saying, oh, we're going to throw all that away. Like the initial slide, you go start coding, I'll find out what the customer wants. So can we do something better than that, where there is still some discipline, some structure, but we have some process in place that is more graceful at dealing with change, which we know will come. And in 2001, the Agile Manifesto was sort of like Martin Luther nailing his 95 theses and kicking off the Reformation. A group of software engineers who said, we're uncovering better ways of developing software by doing it and helping others do it. And we've come to value individuals and interactions over processes and tools. So not that processes and tools are unimportant, but that they shouldn't be the truth. The truth is how the team and the team with the customer interact with each other. Working software over comprehensive documentation. It's more important to have a prototype or a partial implementation that can be commented on and learned from now than to wait until you have a version that absolutely satisfies every detail of what the design docs say. Customer collaboration over negotiating a contract. Not everything the customer wants will be possible, and hey, software is hard. Every bit, it's not like when you build a bridge, you're using a brand new design that's never been used for any bridge. That's pretty rare. But if you're building software, you probably are doing something in there that is new. Because if you're not, you should be using some other off-the-shelf software to solve your problem. So sometimes you'll be wrong about how hard it is to build something, and it's not productive for the result of that to be the customer saying, well, our contract was you would do those things. That's the time when the software team and the customer come together and say, OK, we were trying to do a thing that was new, and it turned out to be harder than we expected. Where do we go from here? And finally, responding to change over following a plan. It's not that you should never have a plan. Plans are good. But a plan is there to give you a guideline and to know when you've deviated from the plan, to give you a signal where you say, well, OK, why did we deviate from the plan? What did we not foresee? So it's not that the things on the right have no value. It's just that the things on the left should have relatively more value. So how do you translate this into a way of building software? Well, first of all, we assume change is a fact of life. Change is what software does well. So we're going to have a very different view of the world. The prototype is always there. In fact, there's no hard distinction between the prototype and the real system because the prototype gets better and better. And the customer is part of that process. Iterations can be quite short. In the real world, 1 week is typical. In our class, it's 2 weeks because of the constraints of scheduling. But basically, every iteration means all the elements of the lifecycle happen. So in Waterfall, we talk about gather the requirements, figure out the architectural changes, do the implementation, do the testing. We're going to do that in every single iteration. It's just that because the iteration only covers a small amount of functionality, right, just enough to get to the next higher level of a better prototype, each of those phases will take much less time. We're going to use test-driven development to reduce mistakes, and I'll explain the rationale for that momentarily. In terms of how do we interact with the customer, user stories are going to help us find a common meeting point where we can agree on what the customer wants. And we're going to use a simple scheme called velocity to get better at estimating how long we think it'll take to do stuff, so that working with the customer, we can prioritize when there's more things to be done than there is time to do them. You'll start each round, each iteration, by talking to the customer. You'll come to some sort of agreement and come up with lo-fi mock-ups of what the customer believes is going to happen during that iteration, what's going to be implemented or improved or fixed. Maybe there was something that you did the previous iteration that didn't quite match their expectations, so you need to go back and tune it. You'll turn those agreements into user stories and scenarios. If you've taken 160 or a comparable class in user interfaces, you know that a user story is essentially a sequence of steps from the point of view of the user, that when the user does this, then they should expect this to happen. Or when the user does this, then the internal state of the app should change in such a way that something is the case. And in fact, we're going to take those user stories and use a tool called Cucumber to basically turn almost English language stories into tests, actually runnable tests, that also, by the way, serve as documentation. Because it is much easier to read a user story written in plain English that says, when the customer does this, here's what should happen, than it is to try to decipher that same thing by tracing through the code. So documentation and tests actually are almost two sides of the same coin in many ways. When you actually come to write the code, we will write the tests first. If you've done test-first development, you probably remember it was really weird the first time you did it. If you've been doing test-first development for a while, you may remember that it's still pretty weird even after you've done it for a while. However, the number of stupid mistakes that it catches and the way that it makes you think about your code makes it well worth the effort. And one of my kind of big messages to all of you is we're going to be asking you to code and think about code in ways that you might not be accustomed to. Have a little faith in the process and try it. It's going to feel weird the first time you do it, kind of like putting your head underwater or something. But trust us, you will not drown. It gets a lot better. So hang in there with us. Measure velocity. A really useful thing is for you to be able to estimate as a team how much you can actually get done between now and the next time you meet with that customer or give the customer the opportunity to give feedback on what you've done. So our hope is that using the techniques we're going to teach you, over time you will get better at doing that. So that if the customer says, I really want X, Y, and Z, your team can come back and say, you know what, in the time we have, we can do 2 out of those 3 things. So you, the customer, need to prioritize which is the most important for your business value, and we'll do those first. And finally, as I said, you're going to be frequently deploying. As you probably know, sites like Amazon or Facebook are deploying new code to production many times per day. I don't really think most of your teams will be deploying many times per day, but you'll be deploying frequently enough that as soon as you've got new functionality that you want the customer's feedback on, it's up and available for them. So you'll do that 4 times because that's how much time we have in a semester. And along the way, we're going to talk about legacy code, design patterns, the interaction between those two, and how legacy and agile are really 2 sides of the same coin. And that's kind of going to be your life cycle. You're going to get really good at doing all of those things. So if you hate the part where you gather requirements from the user, sorry, you're going to do it 4 times, and you get better at it. Okay? So I like to think of just like a shark needs to keep swimming to live, software needs to always sort of be stewarded, maintained, monitored in order to remain alive and remain viable. So think of this as not you deliver a piece of software. What you're doing is you're participating in a process. And that process is ongoing for the life of that piece of software. People may rotate on and off of that team, but the process of how the software is developed is what persists. In particular, the variant of Agile that we mostly use in this class is Extreme Programming, or XP. I kind of think that name is weird because it makes me think of like programming with a helmet on or something. But Kent Beck, who I believe still works at Facebook now, is sort of given credit for putting forth the following rationale. It's like, look, if we're going to do this Agile thing, if the reason we're doing iterations is we want a short iteration so that we can get feedback more frequently, then let's make them really short. Like a week is much better than months or even a year. If it's good to have simple code, then do the simplest thing that could possibly work. Don't try to plan today for all the things that the customer might do with this feature in some possible future. Do what the customer needs now and develop ways to deal with change so that if the customer later needs to do more with that feature, you'll be able to grow into it. If testing is good, and surely we all agree that it is, then you should be testing all the time. In fact, you should be writing the tests almost alongside the code. Right before you write like 5 lines of code, first, write a test that captures what you believe that code is supposed to do. And for me, the big revelation of doing this is not that, yeah, it forces you to write more tests. It does that. But it makes you think about your code differently because it makes you think about, from the outside, what would somebody coming into my code base expect that my code should do? If you have trouble circumscribing that in a test, your code's probably not cleanly factored. And this is one of the biggest revelations to me of really sticking to test-driven development. It makes you think about your code in a more disciplined and structured way. And finally, we're going to talk about code reviews, having your team or members of another team sort of give a third-party opinion on aspects of your design. That's widely considered a good thing. So if it is good, why shouldn't we do code reviews all the time? Let's program with a partner, and in such a way that the partner is always doing sort of an ongoing microcode review. And in fact, let's switch partners all the time so someone always gets to be the reviewer. That also spreads knowledge throughout the team. So all he's saying is we're going to take these things that everybody agrees are good for building high-quality software, and we're just going to take them to their logical extreme, hence extreme programming. When this was all put forward in 2001, some people thought that it was kind of, this is a way to legitimize hacking, right? It's a way to say, oh, we don't need all these documentation, we're going to get rid of all that. And that's, I think, for a long time, the image that Agile software engineering had. It was the thing you do when you don't want to do anything, when you just want to start coding and not have to deal with meetings or documentation. But it is not that at all, right? It is the same life cycle. You still have to know the customer needs. You still have to verify that you built the right thing. But we're going to do those things on a much finer-grained, sliced a lot more thinly kind of scale. It has now become mainstream. So for the most part, most worldwide software companies are now using some form of Agile, especially in their distributed teams. And it's essentially, you sort of need a reason not to use it. If you're working on the kind of project where the customer is not available, or it's a critical system, or one that is rarely going to change, those are great reasons, as in the case of the Space Shuttle software design team, to use plan and document methods. But if those things aren't the case, if you have the customer, if they're willing to be part of the process, if change is likely in the future of the software project, Agile is probably a good fit.